Hey guys, I forgot to give you all satellite data and information to answer questions 9 through 12 on week 5's homework. This is at the bottom of our page for our cloud identification and then before our lab. But questions 9 through 12, the first one is, what is the current cloud conditions over North Dakota? Within the United States, are there any areas of thunderstorm activity? And number 11 is, if you select yes, which states are currently experiencing thunderstorm activity? So I'll talk about question 12 a little bit later towards the end, but for these first three questions, you're going to want to use this satellite data here that I'm providing you. This is taken from the 16th of October, close to 10 o'clock in the morning. So here we can see we have a large band of clouds stretching over the eastern and southeastern part of the United States. Possibly some convection going on off the eastern coast of Florida, as well as the southern part of Texas, and maybe up into the Carolinas and Virginia, going up into Pennsylvania and New York. And what is causing this large feature here to form on our current surface chart? Our current surface chart and radar composite image, we see that we have showers stretching from most of the eastern part of the United States, and a little bit of heavier rain or thunderstorms into Texas, off the coast of Florida and through the Virginias and or through Virginia and the Carolinas as well as a little bit of showers up into the Pacific Northwest. But this is due to a large cold front that's pushing through, causing a little bit of vertical motion to create these thunderstorms, and an inverted trough through, or not an inverted trough, but a trough through the central part of Minnesota. So to answer questions 9, is there cloud cover in Minnesota or over the Grand Forks area up here? Use this data to answer that question, as well as for thunderstorm activity. To figure out where thunderstorms are or convection on visible satellite imagery is you want to look for texture. So if we zoom into this area over here, we can see that we have some nice texture in these clouds, which is going to be vertical motion. We'll see if this will reload now, but you can see the texture in here. So we have some vertical motion within this area, as well as down through Texas. We can see that we have a little bit of vertical motion here and as well on there. And we can compare that to our surface chart, where we had those higher reflectivity values, which indicate heavier precipitation or convection within thunderstorms. The next part of this was to, for question number 12, is find a region in the United States with significant cloud cover. Use data from the METARs to find the base of your clouds in that region, and then use satellite infrared data to find the cloud tops in that region. Verify the cloud top height data by creating a sounding for that region between these two websites, Pivotal Weather and weather.cod, and this is the website that we use in our weather briefings a lot. And then write a short summary to explain if there was a correlation between the cloud height data and the sounding data. So we're going to use band 14, which is long wave infrared, and this is going to tell us the temperature at our cloud tops. So you can see up into here we have some, I guess you could say that's some light blues, some blues and greens. So those are between -30 and -60 degrees Celsius for the tops of these clouds. Up into the northeastern part of the United States, we're seeing that we're around -30, and down into the parts of Florida, we can see greens and red, which is going to indicate between -60 and -70 degrees Celsius. So I'm going to take an example over Kansas here. So don't use Kansas as your example. Pick somewhere up in the Pacific Northwest, over Minnesota, the northeastern part of the United States, southern Texas, or even throughout really any of this area down here into Florida and the southeastern United States. But I'm going to use Kansas as an example to show you on kind of exactly what we're asking you to do in this question. So with this data here in our infrared, we see that our cloud tops are roughly around -10 to -20 degrees Celsius. And down a little bit further down here, we see that they're a little bit darker in color, so probably between 5 and -5 degrees Celsius. So the first part of this question was to use data from METARs. So we can take a look at our recent METARs over this area. This is a little bit further to the south of where I was looking at, but we can click on here and make sure if you're doing this in the future, past, right now, if we're doing this on the 17th or the 18th or the afternoon of the 19th, that you select, how many past hours you want to go back to, so that way you're around 10 o'clock when this imagery was taken. But we have broken clouds at 10,000 feet, and then more clouds at 14,000 feet. So this is what you're going to use to find out where the base of these clouds are at. The next part of this is to use a generated sounding or an archive sounding to find out right here. It's use the verify the cloud height data by creating a sounding for that region between these two websites. We'll take a look at the weather.cod page, which is right here, and I'm going to use the North American NAM Nest model. And again, we're going to use Kansas, so I'm just going to zoom in on here. And we were looking right around in this area based on here where these clouds were located over the central part of the state. So you can just go ahead and click on here, and it's going to generate a sounding for you. Now remember that those cloud tops were around -10 degrees Celsius or somewhere around that ballpark, and this is how you're going to verify based on your soundings, or based on the imagery in your soundings. So I want you to include the pictures of the METAR verifying where those clouds were found at, so that way we can tell that you're able to decode that properly, and then as well as a picture of your generated sounding or your archive sounding. So right between -10 and -20 where we saw that those clouds were located, we follow it up, and right at the top here at around -15 degrees Celsius, again we're between -20 and -10, we see that the dew point and temperature are within 5 degrees, which is going to indicate a layer of clouds, which again is going to be around -15 degrees Celsius, which is exactly what this cloud top data was telling us, is that our clouds are somewhere right in here of that temperature, so that is the height or the top of those clouds. And our sounding right here just verified that those cloud tops, which are indicated right here between our dew point and temperature being within 5 degrees, symbolize that they are between -10 and -20 or -15 degrees Celsius. If you're taking sounding data from the NAM Nest page or the NAM page, make sure that you're using a model run that includes around the time of when that satellite data was given. So if you're doing this on the 18th, you're going to want to go further back under the model runs here and select the 16th at 12Z, or maybe even 18Z, but the 12Z will get you a pretty good, get you there pretty close. So remember that you want to be close to 10 o'clock a.m., so you'll want to be somewhere in this area here, and then you just click to get your sounding to generate, and it's going to pull up your sounding here. And again, you see we find that we're between -10 and -20 for that location, which verifies right here that those cloud tops were between -10 and -20. If you're using, if you can't get your archive data to work because the model run is too far back, so here we see it only goes back 3 days, so you should be able to find it on here, but you can use atmospheric soundings from the College of Wyoming. So if you just Google search College of Wyoming archive soundings, click on the first link, which is weather.uwyo.edu, you can find soundings throughout all the region. Again, under types of plots, make sure that you click your PDF SKU. You want to select your time period for when you are using your thing. So we're on the 16th at 12Z, which is the latest sounding that was launched, and then click on your location. And this location right here is a little bit further to the southwest than our satellite data was giving us. So we're looking a little bit closer over to here, and at the end of this bar we see that the clouds are between probably 5 and -5 degrees Celsius based on our color scale right here. You can see they're a little bit darker, but using this data we find that those clouds right here are between, here's our 0 degree isotherm, here is our -10 degree isotherm, and we find that those clouds right here are around -5 degrees, which again verifies based on our satellite imagery that those clouds were between 0 and -5 degrees right here. So don't use Kansas as an example. Pick somewhere in the Pacific Northwest, over the Minnesota, South Texas, Florida, or somewhere on the eastern side of the United States to do question number 12 for. But if you guys have any questions, feel free to send me an email, or if there was something that I didn't explain very well in this video, just send me an email and I'd be more than welcome to help you if I get time. This weekend is a little busy for me. I gotta work most of the weekend, but I'll try to respond to emails as fast as I can.